All right, so let's see. All right, cool. So welcome to this week's meeting. I'm glad you guys can make it. I know like midterms is up and you guys are getting more busy. So, thanks for coming. All right, so the agenda for today. So we're going to go over the designs for a couple weeks. And we're basically going to try to improve your guys' design every week. So today we're gonna look at it as a team, and then you're gonna take that, take some comments and try to improve it, I guess. That's kind of the same thing as last week, and we'll try to spend like 10-15 minutes on it. And then I'm gonna show you guys how to fill out the design parameters sheet. And then based off of that, we're gonna pick a final design for now because we're approaching the end of the semester and we still haven't picked a final design yet. And I think that's okay, but we'll just pick a final design for today and we'll see how that goes. And then I'll go over the minimum required torque again for a vehicle. I went over it briefly. Well, actually, I did a presentation on the second mechanical team meeting, but I think there was some confusion on that, so I'll clarify that. And then we're gonna go into the longitudinal vehicle dynamics, which you guys will see later. And then based off of that, we created a code that'll show you how it's going to affect the motor. And then we'll have some times for questions, and then I'll give you guys a task for this week. Sound good? All right.
Yep.
Does anyone want to go first? Just like a quick overview of your guys' design. Or if anything, I could go first. Let's see. Yeah, so currently I made 2 different designs so far. Let me pull up the first one. So let me pull up my chat. All right. So this was the same design you guys saw last week. And I don't think I did any changes to it except add some extra brackets. What else? Yeah, and also created the parts list. I counted every piece to make sure that I'm not using any extra pieces. So for the first iteration here, we can see like, oh, it uses only 2 6-inch T-slots. It only uses 2 8-inch T-slots, yeah. So if you guys remember from last week, I did put an order of 2 36-inch T-slots. So I tried to incorporate that into this design pretty much. And the second design is an iteration based off of that. So this bottom piece here is 36 inches. So it passes the minimum required length, which is also 36 inches. I'm not sure if you guys use that in your guys' design, but I think it makes it a lot easier to make sure that it is the minimum required length. I didn't have time to finish the acrylic, but it's the same premise as the first design, except that it uses less T-slots. Yeah, questions or comments? You guys see any error, any design flaws or or if you have a question on why I put these things there or anything, or does it just look good?
I think it looks good.
Thanks. Thanks, Gia. Yeah, I'm still planning to work on it. I didn't have time to finish this week. But yeah. All right. Yeah. So that's my piece. So who wants to go next? You, Alex? Or better question. Have you guys worked on it this week?
Yeah.
Okay, for sure.
I'll show mine then.
Okay.
I could go, I guess. Can you share the screen?
Okay, there you go. I enabled it.
Tell me.
Are you guys still working with Joseph? Or was he kind of busy?
He kind of went MIA.
Really?
Yeah.
Dang.
And,
Yeah, he's been pretty busy. So hopefully after midterms he'll come back.
okay. Sorry about that. Hold on. I'm gonna share my screen right now.
All right, for sure.
So I still need to add a lot of brackets and cut more T slots.
Mm-hmm.
I wanted to do what you did and count up all the T slots and make sure I didn't go over. I need to do that. And then I mean Uriel worked on it a lot as well. But we had to change up a lot of things to secure the payload better. And this is kind of just like a rough idea of. But there's a lot of T slots that go over.
I see.
Yeah, so I did use the 36-inch T slot as well, and I just mounted everything on top of that. And also with this design, well, there was I'm not sure how we would put in the payload or as well. Like that's the only other thing about if we go with this design. I'm not sure how the payload goes in.
Yeah, it's kind of hard to tell based off of that design. Like I would assume that it would be slid in from the front, and then you would
Yeah,
add in those two T slots, right?
yeah, that's a possibility as well, but I'm not sure like how the competition works. Like when do we put in the payload and stuff like that.
Yeah.
But this is removable, right? We could always take this off and then put in the payload and put it back on during the competition? Or is it just completely secured already?
So for the electronics compartment, you see where the handle is?
Yeah.
So that part, it's essentially a lid, and it can be slid out.
Oh, okay.
Yeah. So I think those T slots are kind
Yeah,
of
so this will block it?
yeah.
Okay, so
Yeah. So try to fix that. Yeah, if you guys want, I can help you guys out after the meeting, and we'll talk more about the designs. Um, yeah, I think we'll just meet after the meeting.
All right.
Yeah. And
Not sure if there's any more questions or comments about what I can improve on besides that. Well, still got a bracket stuff.
yeah, you guys are missing all the brackets.
Yeah, since we changed last week, we had the brackets, but since we changed a lot of things,
Yeah, yeah. It's you basically if you change the design, you almost have to start over again, and
yeah,
it's
exactly.
really time consuming. So yeah. All right. Yeah. So we'll go over after the meeting. I want to get through this. So,
All right.
Gio, you want to show your design really quick?
Yeah. Sorry, let me see. Let me try and screen share. Um,
Dude, I got like 5 hours of sleep last night,
damn.
and like my eyes are burning. Yeah. All right.
Can you guys see it?
Yeah.
Oh,
It just says you started the screen sharing. I'm not
uh-huh.
sure. All right, there we go. Yeah.
It doesn't show them. Okay, so um, well, I don't. Let me start off with. Well, yeah. Well, this is my design, right? This is where
Mhm.
the electric compartment is. Right now I was just fixing the battery because I recently found out that it can't be laid down. So I'm
Mhm.
putting it up right now. I put these two slots. This one, I'm gonna put it like somewhere right here. So I haven't done that yet. And I'm gonna put this one up here so it won't like in case if it hits something, it won't jump off or anything. Up here is the payload. And I if I did my if I did it correctly, I don't think I went over any T slots. Like I think I used like just the um right amount. Like I didn't go over with them. And I still need to put my brackets and stuff so to hold the T slots and everything.
Mhm.
But I think everything else is kind of secure. I try to secure like a lot of it with the T slots, but just like Alex said, I wasn't aware that in a competition like we're gonna have to put it in. So I might come up with something else because I think taking these off would be a little bit too time consuming if we have to do it like within the competition.
Yeah.
So I'll
Yeah.
I'll come up with something for that.
Okay. Yeah, that's good. That you guys caught that. Um, yeah, it's maybe it was my fault that maybe I didn't clarify enough. But yeah, so we're gonna be given that during the competition, and we're just gonna have to insert it into our robot.
Mhm.
Um,
So just a quick slip in there, right?
yeah. Some other teams, essentially you just put it on the robot, and then somehow it's secured. Um,
Mm-hmm. I see.
but yeah, yeah, I'll go over that after the meeting.
Quick question. These
Oh yeah.
holes right here, so we're not actually gonna drill them to the thing.
So they're kind of
You see how like there's these holes. I wasn't sure if we were gonna end up drilling them to the T slots or something because that's why I didn't add anything here to hold it because I thought that was like gonna keep it stable for the electric compartment, right?
yeah. So for those holes, they're gonna be bolted down
Oh,
using
okay.
the same bolts on the brackets.
I see.
Yeah.
So okay, nice. So like this could be fine, right? Like this would be bolted onto that. Is that what you're saying?
Yeah.
Okay. Right. So I don't have to really worry much about this one. This one would already be like secured. Just these two, right? I see.
Yeah, yeah,
Okay.
pretty much.
But
Yeah.
yeah, that was it. Any questions or anything?
Good work, good progress. But I think I want to spend time with you guys individually after the meeting,
Okay.
just to give you guys some feedback and just to kind of clarify how things are going to be moved, I guess.
Mm-hmm.
Um, but yeah, you don't have to worry about that for now, but it does look pretty good.
Thank you.
Yeah, does it? Supposedly it does have acrylic on the top.
A fucking yo.
Yo, my boy Yovan, what's going on?
All right, quit wasting your guys' time. My shit's here. Time to put your guys' shits away.
Oh shit.
Let's go.
Yeah, yeah, Yovan, if you want to show off your design, go ahead.
Right now. Right now?
The battery better be up.
Is your guys' shit's that bad? Holy shit. Just follow the. Okay, I guess I can't. I didn't follow directions either. Okay, with that being said,
Yeah, this is being recorded. Yo, no, I'm just kidding.
well, it's only
Oh, no,
that.
actually, it's a bit. Alan, I'll try to talk to you after the meeting. We're just kind of presenting what we've done so far. Yeah, and you kind of came in late, so we got a lot done within the past few weeks. And I'll try to update you after the meeting. But yeah.
Okay, sorry. With that being said, let me show you got my guys' freaking. There's no camera thing. How do I share screen again? My bad. There we go. Screen. All right. Here's my design. Do you guys see it? Hello? Yeah?
Yeah.
All right, cool. So to talk about a little bit of my design,
Actually, wait, before you start, Jovan,
yeah.
can you click on this on the eye? I don't know if you can see my annotation.
Oh
My
yeah, you see a
thing's
bunch
that.
of those little lines.
Yeah.
Oh, wait.
So there's a way you can take it out.
So I go to annotations, or what do I do?
Oh no. Can you see my annotation?
No, I don't see it.
It's the eye right next to the cube where it shows like the three views, an isometric view. All the way at the top.
Well, let me open up. Oh, wait, I have to stop sharing, I guess.
Oh.
No, share your screen again. Are you sharing?
Wait. Okay, I'll show you. I'll show you really quick. All right, so you guys saw like a lot of sketches on your designs, right?
Yeah.
Yeah, and there's a way you guys can take it out. So if you click on this eye here,
Oh, that thing. Oh, fuck it. Okay, say less.
you're just gonna click on sketches.
View sketches, got it.
Yeah, so it's gonna take away all this.
That shit was annoying me for like the first 30 minutes. I was like, what the fuck is this?
Yeah. No, I mean there's a purpose for that though. So when you're mating, these brackets, they're not completely 1 inch wide, so you kind of have to align the holes with the line. So the center of the circle with the line, pretty much.
Oh, okay.
Okay, enough talking, peasants. Is Gary here? I fuck with Gary on heavy.
Gary is not here.
Fucking Gary, fucking lied. All right, so here's my little eye. Okay, here's my robot. To say a little bit about itself, it's 36 inches long, 25 inches wide. I do have plans on 25 inches high. I do have plans on making higher, and 25 inches wide if you include the wheels, 18 if you include the chassis. that has to be worked on. I didn't have time, whatever. With that being said, let's get into it. So battery at the bottom, drawer assembly around top of it, and then payload horizontally like this.
Mhm.
I guess you guys are interested with the battery first, with this whole configuration. Let me explain. Um, so the whole point of this configuration is to essentially make sure that the battery doesn't move, whatever, let's put it simply, for the lack of a better word. Um, so there's T-slots in the back. I'll explain the bracketing in a bit. So there's T-slots in the back, preventing it from sliding backwards. There will be T-slots or some sort of 3D printer bracket in the front to stop sliding forward. I didn't add that on, that's fine. There's left and right. I'll explain that left and right later. I haven't done up and down. I didn't have time, whatever. I guess to explain the left and right. So, I mean, the reason why I kind of did this is because, I mean, out of necessity. Um, the issue was, do you see these T-cells right here? I could not move them wider whatsoever. I don't want to map it out for you guys, but just take my word for it that if I can't move this wider because of this motor and gearbox, whatever thing. So these had to stay. And the issue is the battery is just a little bit too wide. So with that being said, I couldn't use these T-slots for any sort of fastening reasons for the battery. It could be used as support, but can't be used as fastening. So I had to create this mumbo jumbo to fasten it. Um, so I added like 5-inch T slots, but it turned out there was a 1/4-inch gap. My bad, Tim. Were you trying to say something?
No. I'll keep going.
Sorry. So yeah, I added 5-inch T slots, so there's this 1/4-inch gap. My plan is to fill that 1/4-inch gap with some sort of like rubber or foam. Not only will that like keep it in place, that's A. B, it'll also like dampen any vibrations. So kind of like kills two birds with one stone. As you could tell, I mean, as a result, it has to be heavily bracketed, but I mean, so be it. I probably could have like looked into I probably could look into 3D printing a bracket for this thing and probably call it a day, but I mean, as of right now, this is how it is, so just deal with it. The payload is fast and pretty simple. Again, this seesaw is preventing it from going backwards. These vertical ones from preventing it from going left and right. And yes, I know there's a thing right here, but that's just to slip it in. Then right here we could either like fasten it again with another T-slots, or I was thinking about using like corner brackets, just like tying corner brackets here, tying the corner bracket here. It should be well enough. And then these, you just screw it in. Couple things because so do you see how this is like kind of like a little bit upwards 2 inches? That was intentional. Remember, this is 8 inches in diameter or 4 inches in radius. This is 6 inches long, meaning there are 2 inches difference. So I kind of like combat that 2-inch difference by raising this part a little bit. So now it's level to the ground. And if it's not, we could use 16-inch T-slots and this will be like, whatever flushed. So that's that. The only thing is, because of the way that this is designed, I know Tim said no 14-inch, that couldn't be helped. All of this is 14-inch, and then these are 14 inches. It can be helped. So if we are going to do this design, we are going to have to get more T slots. But the good thing about this design, I checked it out. I don't know if you look at the numbers, Tim, but like it does have pretty good like center mass. Like the center mass, here. Mass. Oh yeah, mass properties.
You
My
passed it.
bad. Yeah, there you go, son of a bitch. So this entire thing with like all these included is 130 pounds.
Mhm.
I don't care about the volume.
Uh,
The center mass is pretty close to this thing. When it says 130 pounds, that means chassis, motor, brick, everything. 130 pounds. So the entire robot will be about 130 pounds over the motor. So sorry, that's the overall mass. The center mass, it says 16 inches, but that's 16 inches from the that's 16 inches from the origin. The origin is about 3.55 inches away, meaning this is like, so the center mass is like about 13-inch inward. So
Wait, Jovan. So I'm gonna go over that today on how to fill out the design parameter sheet, and I'll be going over that.
I kind of already filled it out, so too late.
Okay.
There's a thing. Why isn't there a thing where the center mass pops up? I want to zoom into the thing so I can kind of show you where it is. Evaluate mass properties.
Yeah.
I apologize.
Yeah, let's try to.
But anyways, oh, here it is. So the center mass is like literally right here, meaning it's closer to the front, which is a great thing. Meaning a lot of load will be on the front tire, which is what we want. That means better traction. That means less load onto this back pivot wheel, the caster wheels, and then other BS. Oh yeah, and the motor has to work a lot less whenever it turns. So things like that gives that an advantage. There are 4 caster wheels to give it stability. So overall, this is my design. What do you guys think?
Looks pretty good.
I'm not done with the bracketing. My bad. The only thing is, like I said, with this design, it does a lot of things great, but the couple of things that we have to consider is we're probably gonna have to order more T-slots, like 5, wait, 1, 2, 3, 4, 5, 6, 7, 14 inches, however that may cost. So we have to basically buy more T-slots on top of that. It may or may not be wide enough. Like I said, it's 20. Like when I did a thing, it like from here to here is 25 inches. This wheel's backwards. It's bugging me.
Wait, also, I don't think those are the right wheels.
What do you mean?
Am I right? Because
well, yeah, obviously, but I mean, I don't have the dimensions for that wheel, except for that's 8 inches in diameter.
I think the actual CAD model was uploaded to the parts list.
Well, whatever. As far as I could tell, it's 25 inches, 25 and a quarter inches from the wheels. So the width of it may be kind of buggy. I could probably like look into it to make it wider somehow, so it could fit the 24-inch criteria. But so as of right now, from chassis to chassis, it's not wide enough, and from wheel to wheel, it may not be wide enough. So fuck me. So those are 2 things that we have to consider. So more T-slots, not wide enough, but everything else is good. Like I said, center mass is pretty beneficial. This whole layout's pretty beneficial, and the entire robot's about 130 pounds. So
yeah, it looks good. I'll meet with you sometime after that meeting so we could talk about it more. But
no problem. Oh goddamn, I'm in trouble.
Hey, Jovan.
Yeah.
Did you pull up your design again?
You piece of shit. Share screen. Do you guys see it?
Yeah.
I don't know how the fuck they get rid of this pink thing.
All right, so can you zoom into like the electrical compartment section?
Yeah. Oh yeah, definitely.
Are you gonna be able to slide that in and out, or how are you planning that?
Oh yeah, the whole point of the battery is to basically like slide in and out.
No, for the electrical compartment, because I see like the front where the handle's at. Obviously, the box that's gonna intersect. That's gonna interfere with the bracket. So like, how are we planning to take that out, like in and out?
Oh, like this. Oh, I guess it is sticking out. Are you talking about the fact that it's sticking out?
No, I'm saying that if you pull it out from the front, it's gonna keep hitting that bracket. It's not gonna. The front bracket that kind of.
Oh shit! Do you have one of those like brackets where like the corners are kind of like chisel off? Like
yeah, we have them.
Yeah, we do.
We can use those.
Okay, then use your imagination, Richard.
Okay.
Just based off what you were given, so that's why I was like.
All right. Okay, I guess thanks for pointing that out. Anything else? And like I said, the only thing I didn't do is I wasn't able to count up how many brackets, how many T-slots we needed. I did, like I said, for the most part, I did use the T-slots that we have, except for these 14 inches, but that can have been helped. So it would mean we have to order more, however that may be. I could like honestly give you guys a little rough estimation, like in a literal like 30-second.
Okay.
1, 2, 3, 4, 5, 6,
Yeah,
7.
that's fine, Jovan. Yeah,
It'll
kind
be
of
like
have to.
it'll be like $35 as of right now.
Looks
So,
good though. Everyone
thank you.
looks pretty good.
Thank you.
Yeah, so I'm gonna kind of go over how to fill out that iteration parameter worksheet, which is on the Google Docs. So let me just try to pull it up. Okay. Yeah, so this sheet here is going to be on the Google Docs, and I'm planning for you guys to fill it out this week. Total size, I guess this is arbitrary, but you can fill this out. Okay, so for the total T-slot length, so when you guys count your the number of T-slots that you guys have, so the way I did it was I kind of organized my T-slots into this folder here, and I literally just typed out the length of the T-slot. So for example, like there's 516, so I'll type in 16.
You really messed up my numbers, Tim.
And essentially you're going to do that for all the T-slots, and make sure you don't forget about the mirrored component. So once you do all that, you can get the sum of your lengths. So we can get the number of inches on the T-slot. So this is going to determine the weight of the T-slot chassis of the yeah. So for that, let's just say that it was what was it, 486?
What the X or Y? What the XDN?
What was that?
What's like for what's compliant?
I'll show you guys after.
Oh, I mean, okay.
Yeah, and then so once you guys do that, so how are you going to get your center of mass? So here's the way I want you guys to do it.
Oh, my bad. Do you want the X direction first, and then the Z direction, or?
We'll
Or
probably do
Zenith?
X, Y. Well, I only care about the X
Oh,
and Y.
you know what I mean by fuck the fucking elevation. God, you have to be so.
Yeah. So
Okay, X and Y, got it.
all right, so I'm gonna enable my sketches.
Oh, that's right. My bad. One more thing about my center of mass. It's 13 inches inward, means pretty close to the front, and remember the whole thing's 36 inches, and it's 16 inches. Like high, like the Y elevation is basically dead ass in the middle, like in respect to like the Y direction.
Okay.
So
yeah. Well,
sorry, my bad.
It's okay. Well, we'll go over that after. You guys will see how it affects your dynamics.
Ooh.
So how I want you guys to do it is I want you guys to create a sketch on any flat plane here. So I just normaled it to the side, and I'm gonna click this bracket here and create a sketch. And what I'm gonna do is I'm gonna create a point on the bottom where the very most bottom of this wheel, which is this point here. So I'm going to do that. And then I'm going to create a vertical line and a horizontal line. Like that. So you should have something like this. Okay. So what I'm going to do is I'm going to click on this point here, and I'm going to go to coordinate system.
I kind of use a plane, but pop off.
Yeah, so you're gonna create your X and your Y axis. I don't really care about the Z axis for now, but so you're gonna do that. So you have to make sure that positive direction, positive X, positive Y. And once that's done, we can get the center of mass basically based off of that origin.
My bad. Can you repeat like how you reset the origin?
So
My bad.
yeah, that's cool. So basically, we're gonna sketch on a normal plane. It doesn't matter. I guess it
Yeah.
doesn't matter where. All I care
Yeah.
about is the X and Y direction, right?
Hmm.
And then you're gonna create a point on the very most bottom of the tire. It should
Oh, okay.
like automatically click
Okay, got
for
it, got
you.
it.
Yeah.
Mhm.
And then you're just gonna create a line, a vertical line and a horizontal line.
Okay.
Yeah. So once you're done with that, I want you to click on this and then create the center of mass based off of that.
Oh, all right. Let me do that right now.
Yeah.
Thank you.
And you guys can look over the video again if you need some need a refresher. So I have my coordinate system now, and I can get my center of mass based off of that. So I'm gonna go to mass properties, and what you want to do is you want to make sure that you're in the right coordinate system. So your center of mass is based off of your origin, pretty much. So since I created this coordinate system 2 here, I'm gonna click on that, and it's gonna calculate my center of mass based off of that. So I have my X and my Y here. So let's see, my X. Oh shit. Sorry, hold on. Yeah, so my X is going to be 6.75 inches and my Y is going to be 11.7. And you guys will see that, see why it's important later. So yeah. The drive wheel tire distance, I guess that's also arbitrary. The way you would do it is you would just create a sketch from the point here to the point there, to find your distance of your tire. So I'm just gonna put I'm gonna say 24 for now. I don't want to waste any more time. And then for your T-slot length, you can get the mass. So what I did here, I actually got the mass for 1 inch of T-slot. So all you have to do is drag it down, and then it'll calculate your, I guess, your mass for you. Mass in pounds. And then you could divide it. You can multiply by gravity to get your weight. But that's okay. We'll just put this for now. And then for these compliant parts, so I'm gonna be checking in with you guys if you guys meet these requirements. So for example, on this design, the camera and the LiDAR T-slot is included here. So that means I have a place to place my camera and my LiDAR. All we have to do is just make some mounts for that. So, but all I care about is the T-slot. Make sure you have the T-slot there. So since I have it, I'm gonna put yes. For the mechanical e-brake slot. So remember from the rules that it has to be 24 inches from the ground. And all you have to do is just make sure that it's 24 inches off the ground and you have a place to put it. I guess for this design, I'm planning to put it here. So I want to put that as yes. And then the next section, the battery/battery mount. So make sure you guys have the battery in your design. Make sure that it's upright, and you have to make sure that it's somehow mounted onto the chassis, so it's secure. Yeah, so for this one, I do have one. It's upright. secured. You put yes, and then we're gonna keep on going, but I'll meet up with you guys after the meeting to kind of help you guys out with the rest. So we're just gonna fill it out one by one, pretty much. Does anyone have any questions? Can I get on that?
No questions, we hear the answer.
Thank you. Okay. All right, so I'll be moving on. Yeah. So I haven't been looking at the chat, but okay. All right, that's fine, Alan. Thanks for joining us.
It's not fine. It's never fine.
All right. All right, so the minimum required torque. So if you guys remember from the second mechanical team meeting, I went over this. Are you guys still kind of confused on this topic? I could like quickly go over these forces here that the vehicle has to overcome. Yeah, so I think the biggest part was the rolling resistance. So basically what the rolling resistance does, oh, actually, I just realized, can you see my screen?
Well, I'm messing around with this thing.
Okay.
Yeah, I see it.
Okay, so when a tire is rolling, we notice that it starts to deform here, and it starts to reform back on this side, right? So that's considered rolling resistance. So basically, when it deforms, it deforms in a certain way, like this. And when it unloads at a different rate than the unloading. So you would get a curve, something like this. And this curve is called the hysteresis curve. So basically, the more space that you get in between here, the more energy is lost. Does that kind of make sense? So if you have a tire that's rolling on the ground, it'll eventually stop because of rolling resistance if there's no other forces acting on that wheel. Right. So that's rolling resistance. Right. And then F of D is drag force, F of A is the acceleration, and F of GR is the grid resistance. Yeah, do you guys have any questions? Or kind of good on that? So this equation here is just to determine the minimum required torque. So that kind of comes into play when you want to pick your motor, for example. Yeah. Okay. So I'm going to move on to the longitudinal vehicle dynamics. All right, so this is a big portion of this workshop. So spent a lot of time trying to figure out like vehicle dynamics. So I'll go over that. And then you're gonna see why the center of mass is really important. So I'm gonna go over a vehicle in a flat surface. So let's just take our robot, for example. It's gonna look something like this. Right. So let's just say that we have the center of mass here. Right. So what are the forces acting on the robot when it's accelerating this way? So this is the front, this is the back. Yeah, so if this is our front axle, we have a force that's driving it forward, right? So I'm going to call this F of C, for example, right? And then when you're accelerating, the car experiences a force in the opposite direction, right? So as you accelerate forward, you also get another force pushing it back, which is ma. So the faster you accelerate, the more force that you feel going in the opposite direction. Right. So we also have drag force, which if you guys remember, it's like, I'll go over that formula later. And we also have, we actually have rolling resistance here from the tire. Right. So that's that. We also have a normal, actually, sorry. We have a weight, mg here, right, which is the mass of the whole entire robot times your gravity. And we can say that there are normal forces here on the axles. So I'm going to put this as normal of the front tire and normal of the rear tire. Right. And this is, so remember how I filled out the center of mass distance? So the distance from the front tire to your center of mass is going to be considered B. And from your center of mass to your rear tire is going to be considered C. And B plus C is equal to your total length. So it's like, now, what can we do with this? So we can split it off into the X and Y direction, right? So in the X direction, we can say that it's kind of like statics. So if you guys are struggling with statics, this is kind of statics heavy. So this is like a good review for you guys. All right, so let's look at the forces in the X direction. So I'm going to create an axis here. This is my X. This is my Y. We know that, let's just say this is positive. This is positive. All right, so if you say the forces in the X direction is equal to 0, so essentially we have 1, 2, 3 forces positive. So force of your drag plus force of your rolling resistance plus ma minus your force here that's driving the robot is equal to 0. And essentially you can say that the summation of your forces is equal to ma, and your acceleration is equal to your summation of your forces divided by your mass. Right? And our summation of the forces, we know that the force driving the robot is positive minus force of drag minus force of your rolling resistance divided by mass. Now it's like, does that make sense? Or do you guys have any questions so far?
Crystal.
All right, cool. All right, so in the Y direction, what do we have? What forces do we have? We have 3 forces, right? So we can say that the summation of your forces in the Y direction is equal to 0, and it's going positive up. So we know that the normal force on the on the front axle plus normal force on the rear tire minus mg is equal to 0, right? So there's a way we can find your normal force on the front axle and the rear tire, and then the rear axle. And the way you would do that is you would take a moment at this point, right? So let's see, let's do it. So moment at front wheel. So let's see. Moment front is equal to 0, and we know that if it's counterclockwise, it's positive. So let's see. So we have mg that's going clockwise about this point, right? So that's going to be negative mg, right? And then we also have ma, which is also clockwise. So that's going to be negative ma. And then we also have this normal force, which is going counterclockwise, right? And oh, I forgot to. Sorry, I forgot one thing. The height of your center of gravity to that wheel is h. So mg times b minus ma times h plus nrl is equal to 0. Right? So you can isolate your nr. So we'll get something like nrl is equal to mgb plus mah. Right? So you can take out your m, so you'll get gb plus ah divided by l and r. Now, basically what this is saying is as it accelerates, so this is your static load. So you're always going to have this static load, but this function here is it's called your load transfer. So as it accelerates, you get more force on the rear tire, right? And that's a function of your acceleration times your height of your center of gravity. So you guys can see how that affects the dynamics, because if you have a really high center of gravity, you're going to get more load transfer on the rear tire. Does that make sense? So you can do the same thing for the front tire. And I'm going to simplify this. So it should be GC minus 8H. So for the front tire, as it accelerates, you get less normal force on your front tire, right? So this is kind of why you want your center of mass to be lower, so you get less of a load transfer. That makes sense. Right, so why does this matter? So we know that traction, so force, your traction force is equal to your normal force times your friction coefficient, right? So if we get this equation here, A is equal to summation of F is divided by M. This turns into FC minus F D minus force of your rolling resistance divided by M. And we know FC now because we found the normal force and we have the traction equation. So this is traction. So now we can get the acceleration of the robot based off of this equation. So it'll be ML GC minus AH times your friction coefficient minus your force of your drag, which should be 1/2 rho of your liquid times your area. What am I forgetting? Oh, times your drag coefficient times V squared minus your friction of your rolling resistance, which is your normal force. So your normal force times rolling resistance. So you guys can see how it's like really, it gets really complicated. Yeah. Are you guys, are you guys still with me? Does that kind of make sense? So
yeah, acceleration equals F over M. Got it.
yeah. So let's see. So the reason why this is important is because if you don't have enough traction on your front wheel, it's not even going to drive. So the idea is you want your center of mass closer to the drive wheel and as low as possible, so you get more traction. And so we have this equation here, right? A is equal to summation of F over M. Quick question for you guys. Is it better to add more mass so you could get more traction?
Yes and no. Yes, we get more traction. No, that means our motor has to do more work eventually or inevitably.
Yeah. So basically, adding more mass to get more traction, they just cancel out. So you're just making more work for the motor. So this is why if you minimize your mass, you get more acceleration. Oh yeah, sticky tires. Yeah, so that's this equation here is for a front, a flat surface. And what we also want to do is find the dynamics for when it's on an incline as well. But I think I'll go over that next time, just because I don't want to keep you guys here for any longer. And also go over the code next week. So for the tasks, I'm going to meet with you guys after the meeting to see where you guys can improve, and I'm going to ask you questions on how things work, so you guys get like a better intuition of the design, and also you guys can get more SolidWorks practice as well. And then I also want you guys to follow this tutorial. It should only take around 20 minutes. So this is going to approximate the drag coefficient for your design. Can quickly go over this. Yeah, so this is just a quick tutorial on how to find your drag coefficient based off of your design. It's pretty easy, just follow it. But one thing I want to note is that instead of a sphere, you guys are going to create your own shape based off of your design, because the drag coefficient is highly dependent on your guys' design. Yeah, so you're going to do that. You're going to follow up to step 16. You guys can do the rest, but I guess it doesn't really matter too much. And then first step, let's see, when you define your x direction of your flow velocity, set it as 6.7 meters per second. Yeah. So yeah, and you might be asking like, why is this important? So in this equation here, your drag coefficient, we don't really know what the, sorry, for your drag force, we don't really know what your drag coefficient is. So this is an unknown. We can say it's an unknown, or we can state that an assumption. But if we want to get a more accurate number, we want to find the drag coefficient. Yeah. Does anyone have any questions? So let's see. We're gonna fill out the design parameters today, which is the Excel sheet that I showed you guys earlier. And then we're gonna keep on working on designs, and we're gonna approximate the drag coefficient. And I don't know if this is too long for you guys, but I did want to show you guys a code based off of this. Yeah, Jose and I created it on MATLAB, and based on your guys's parameters, let's see, like your center of mass, your weight, and your distance, we can find how it affects the motors that we have. But yeah, so yeah, are you guys kind of clear on your guys' task for this week?
Mm-hmm.
Okay. It's kind of quiet today.
Also, one more thing, you guys, about the flow computational model. I will be writing up a lab report for that. You guys don't have to get involved with the lab report. That's fine. I'm kind of like writing it up. But like when you guys do your flow analysis on whatever iteration you guys may be doing it on, just send the results to me. Then I could go ahead and like write that up in a report. That's it.
Yeah. Yeah, and yeah, I can show you individually how your design is going to look like as it accelerates with the code. Well, for a flat surface for now. But yeah, I think that should be the end of the meeting. If you guys don't have any other questions or concerns, I'll be meeting with you guys individually to help you guys with the design and to fill out this sheet. But yeah, that should be it for this week. Yeah, if you guys have midterms, please focus on that. This is, just keep in mind, like, this is an extracurricular. Your classes should come first, and I think from now to the end of the semester, we're gonna be pretty busy with classes. and I know I'm kind of giving you guys a lot of things to do, so I'm kind of lenient on that until we reach the end of the semester. For the winter, I guess for winter we can heavily focus on all of the things that I've been talking about. But I do want to get you guys exposed to this now, so you guys have an idea on how it works. Why 6.7? Wait. When are we building? Oh, when are we building? Okay, so I think by next month on the 20, by next month, we have to build a design so that we can have a model for the EE and the CS team to test. So this is why I kind of wanted to pick a final design for now. So that we have a model ready for them. But I still want you guys to work on your iterations so you guys can see how, where you place things affect the vehicle dynamics, if that makes sense. But yeah. Yeah, I think that should be it. Thanks for joining this week's meeting, guys. Kind of missed Joseph and Jose. Ah, sad days. Yeah. Does anyone want to meet first?
Yeah, I can meet first.
Okay. Yeah, I'll type in the chat when I'm done with each individual. Yeah, because I think meeting individually might help you guys more than presenting for now. So.
All right, cool.
Yeah. Yeah. Okay, Udi, I'll meet with your team later. Yeah, and then Geo. Okay, I'll meet with you as well. And okay, yeah. So let me stop the